Let's do it. Yeah, this one. So what was the question? For a traveling wave, now we are solving which question? Question number 10. Okay. For a traveling wave traveling along a straight line, the distance between the two peaks is 5 meter, while the distance between one crest and one trough is 1.5 meter. Okay, clear? That is not maybe that is I think not 1.5. That is I think 15, right? 1.5. Then take 1.5. You are getting the answer. Then it is 1.5. The possible wavelengths of the wave are, how to solve it? Distance between the two crests, it may be 2 like this. So if I am talking about 2 crests, it will be in terms of lambda, right? So I will take it n lambda. Okay, so the 5 meter is going to be answer number 10. 5 is going to be n1 lambda, because n we have to use again. The distance between one crest and one trough, how much it is going to be? So it is going to be 2n2 plus 1 lambda by 2. It is equal to how much? 1.5. Okay, if I divide them, you will get what? 3 by 2, 10 by 3. If you, okay, we will do that later on. So okay, so that 2 will go there. 5 by 3. Okay, 5 by 3 is n1 upon 2n2 plus 1. Okay, now what you have to do here? Hit and trial. Yes. You will put the value of n1, you will get the answer of something like that. Or any other way?
n1 is 5 means n2 will be 1.
n1 is 5 means n2 will be 1. Acha, that kind of ratio we are taking. Okay, so where I can start from? If I take n1 into 1, if I take n1 as 1, how much will be getting?
Take N2.
If I take n2, it will be easy to get n1.
With coefficient replace.
So I will assume n2, right? So if I take n2 equal to 1, so that will be 1, 3, 3, n1 will become 5. Okay, if n1 is becoming 5, then lambda we can get from this equation. It will be easier. Lambda will become, from this equation, it will become 1. Okay, now if you are I am taking n2 equal to 2, (25 by 3) and 25 by 3, acha, 25 by 3, it will become 3 by 5. Acha, n2 4, it is coming, right? Okay, so n2 equal to 4 I am taking. In that case, 4 to 8 or 9, 15. So n1 will become how much? 15. So n1 is 15. So lambda will be 1 by 3. Okay, so this kind of ratio is coming out. Okay, 1 by 3, 1 by 3, 1 by 5. Okay, got it. Question number 11. A traveling harmonic wave is represented by equation y equal to 10 raised to minus 3 sin 50 t plus 2x. Which of the following is a correct statement about the wave? Okay. Okay, try this. The wave is propagating along. It is given in the addition, so it is definitely going along negative. Okay, it is going along a negative. Omega is given k is given 2. Omega 5. And this is what? K. So omega by k, that will be your V. Okay. 12th one. Wave is represented like this. The wave velocity is twice the maximum particle velocity. So answer number 12. Okay, answer number 12, they are saying maximum particle velocity will be how much? So maximum particle velocity is going to be how much? A is how much? 10 by pi. Omega will be how much? Omega will be 2 pi upon t. So any other thing is given?
Just keep omega so it will get cancelled.
Let's keep it like this then. And they are talking about wave velocity. How much is going to be the wave velocity?
Omega will
Okay. We will find k and then we can find. Okay, not an issue. So wave velocity is twice. So this is acha, wave velocity, that is omega by k is equal to twice of 10 upon pi into omega. Okay, so omega will get cancelled. K will be how much? Pi by 10, and I can write how? 2 pi by 20 I can write. So lambda is going to be how much? 20.
5 by 20. K equal to 5 by 20.
Okay, pi by 20. So this becomes 40. So lambda will become how much? 40. 13th. Traveling wave in a stretched string is described by the equation y equal to the maximum particle velocity. A, clear. Okay, let's move ahead. Question number 15 is easy. In a wave motion, y represents what? Displacement. Done. 15 done. Now we are talking about question number 16. 15 done. Let's talk about question number 16. Question number 16 is y in terms of x and t is given 0.8 I cap multiplied by 4x plus 5t square divided by 4x plus 5t square plus 5 represent the moving pulse where x or y are the meter, t in second. Okay, so let's check it properly how it is given. divided by, that is divided by, okay, 0.8 divided by how much function? 4x plus 5t square plus 5. Understood? I cap will be in multiplication, right? Clear? Okay, it has to be in multiplication. It represents the moving pulse. So y is given in terms of I cap.
I cap in x direction.
Yeah. So wave is moving like this, na? Then wave.
How y can be 9?
Wave is moving, maybe moving vertically, na? So y will be like this, na? So something like that is given. Okay. So if y in terms of x and t is given in terms of I cap, that means wave will be moving vertically. Got it? As per my understanding, we will check. Okay. Find it, not an issue. Find the answer. Pulse is moving in plus x direction. B is what? Pulse is moving in 2 seconds. It will travel at distance of 2.5. Okay. So this is given what? You can take x plus vt, right? You can take 4 common, not an issue. Okay. if you take 4 common from it, what kind of equation you will get?
16 plus
0.8, okay, I cap divided by, if I take 4 common, 16 x plus 5 by 4 t square plus 5. Clear? Now this is what? Velocity, x plus pt. Got it? So velocity, how much you are getting? 5 by 4. So they are saying in 2 seconds it will be traveling how much distance? Correct? 1.25 in 1 second. This is meter per second, right? Okay. So in 2 seconds it will be, this is how much? 1.25 meter per second. So yes, in 2 seconds it will travel how much? 2.5 meter. Absolutely. So B is correct. Now maximum displacement is how much?
4.
0.16 meter. How you find the maximum displacement?
A omega.
A.
See, A.
Got it. So square of this 16. So how you find it in this case? How much is the maximum value here?
That minimum value means we'll get maximum.
Maximum.
The bottom minimum if you get, then you will be getting the maximum one. So how you will be doing that?
Minimum. That square values should be 0.
The squared value should be
0.
0. It cannot be 0.8 by 5. 5 will be 0.8 by 5. Yeah, 0.8 by 5. That will become 0 because we can take the negative. Okay. So now in that case, 0.8 by 5 will be
0.16.
okay. Then C will be correct. Symmetric pulse you have to draw. You have to draw whether it is symmetric by y-axis or not. Otherwise, you will not be able to get it. Can you draw this one?
Like 3 variables only.
T equal to 0. Take T equal to 0. See, try to understand. The same wave is moving, right? The same wave is moving. Got it? So you can take T equal to 0 in this equation. What you will be getting? If I take y will be how much? 0.8 upon 4x whole square plus 5. This is you have to draw. Try to draw taking a value of x12 minus 1 minus 2. Now that is very simple. Try to understand. If I put, see here, Ansh, if I put the value of x minus 1 minus 2 or plus 1 plus 2, it is not going to matter because this is what squared. So diagram about y axis on both sides it will be same. If I am trying to draw y versus x, understood? If here it is like this, on this side it will be like this as well. Got it? Because whether I put the positive value of x or negative value of x, y is going to be positive. So it will look like this or maybe like this, but it will be symmetric. So it is going to be symmetric pulse. A option I have confusion, pulse is moving in plus s direction. No. If y is having this kind of vibration, pulse may be moving up and down. Got it?
So then maximum displacement in x-axis they are asking, right?
Maximum displacement in?
Means this.
Wave is moving like this or maybe moving like this. Got it?
So we have to find x, right? But we found y.
No. Maximum displacement of the particle.
It will be in x direction, x, right?
Yes.
1.0.16 distance, it's y, right?
You are getting confused or maybe we are getting confused. Okay, what you are trying to say? We are trying to find the value of y, maximum value of y.
But maximum value of x we need to find, right?
You are getting confused between y and I cap. When it is going like this is taken y and this will be taken x. Y is what? In our questions, y is what? Displacement of a particle from its mean position. What is x? Direction which the wave is propagating, or maybe the opposite of what the wave is propagating. Now y is given in terms of I cap. So how the wave is going?
Like this, if we consider this as
No, y is given in terms of I cap. Y is given in terms of I cap. That is particle is having like this. If the particle is vibrating like this, That means wave will be going like this or like this. So what you are trying to find here, which you are calling x coordinate, that is not, that is y.
It is y.
Y. You will be drawing a different diagram here. See, it will be like this. In this case, this will be y and it will be like this. Got it? For this particular case, because they have given the fraud stock market. Anyways, all the frauds are calling me these days. Brotherhood. Anyways, 17th. Got that idea? Got about that? Let's cross check the answer. Okay, that one was question number 16. Yeah, B, C, D and D. B, C and D. Clear. Solve 17. These are multiple answer questions. Okay. Solve this one quickly. Question number 17. A transverse sinusoidal wave of amplitude A, wavelength lambda and frequency f is traveling on a stressed string. The maximum speed of any point on the string is v by 10, where v is the speed of propagation of the wave. If a is 10 to the power minus 3 meter and v is 10 meter per second, the lambda and frequency is given as. Eighteenth is what? Okay, kx plus omega t. First we will check 17.
AC.
Getting it? Sign. Why have you drawn 3 circles? Naveen, you are finding moment inertia in this class? Okay, just like that. All these 3 things are given: amplitude A, wavelength lambda and frequency f. We will solve question number 17 now. Okay. The maximum speed of the any point on the string is v by 10. Okay. V by 10 is v is what? As the speed of propagation of the wave. If a and v are given, then lambda and f. Okay. Maximum speed of any point on the string will be how much? Equal to a into omega, and that is given v by 10. Okay. Now a is given, frequency is given, so this we can write 2 pi frequency equal to v by 10. Okay. A is given, B is given. Then you can find the frequency. Simple. A is given how much? 10 to the power minus 3 into 2 pi frequency equal to V is given 10. So that will become 1. Okay. So frequency will be how much? 1000 upon 2 pi. This is the frequency you are getting. 1000 upon 2 pi. Yeah, third option is correct. Simple question. Now lambda will be how much? V equal to lambda into frequency. So lambda will be V by frequency, right? So lambda will be, velocity is how much? 10, frequency 10 divided by 1000 into 2 pi. Okay. How much? Okay. A option. Any other option you are getting? No. Acha, lambda and F is asked in the B and D. Clear? This is clear. Question number 18. First of all, it can be in the form of kx minus omega t, not an issue. Okay, so that means
A and C are
c can be, because I can write this in the terms of
cos theta plus cos
clear?
theta.
Okay,
A and C
we can write in the form of what is the formula?
plus
Cos 2 theta is equal to 2 cos square theta minus 1, right? Okay, 2 cos square theta minus, so this will yeah, I can write it 1
plus
cos 2
kx plus omega t by 2.
divided by 2. Yes, so this is also not an issue, we can write it. What about first one?
Multiply divide 2, then
Yeah.
2 cos A sin B is sin A plus B plus
Okay.
sin A minus B.
Wait, so I will solve it here. We are taking 1 by 2 into 2 sin omega t cos kx. This one, right?
Yes.
Clear? So how we can write this one?
Sin A cos
No, no.
sin A plus B plus sin A minus B
Sin a plus b.
plus sin A minus
Okay. Sin a plus b plus sin a minus b. Okay, this is what you are getting. So it is a addition of the two waves like this. Okay, we can take the a. What about b is not there, d is not there. Okay, so a and c is going to be the answer.
B we can write as kx minus omega t to kx plus omega t. That won't be.
Will that be considered? No, there is no wave like that. Generally, you are using in trigonometry. Whenever the term is coming, that exact term should be coming. Kx minus omega t or kx plus omega t.
For like exception,
But you are writing kx minus omega t, right? First of all, in subtraction, how you will write it?
this is kx minus omega t into kx plus omega t.
Still, how it will be? Kx minus omega t and kx plus omega t is the substitute of t. That's it. There is no amplitude, there is nothing like that. There is no amplitude here, there is no vibration of the particle. You are taking kx minus omega t and kx plus omega t. So kx omega t, they are having unitless. Got it? Even if you are multiplying them, you are getting nothing. Got it? Kx minus, that is clear. Omega t is unitless, kx is also unitless. That's why you are getting the radian angle, kx minus omega t. So if you are, even if you are trying to sort it out, it is unitless. Got it? Okay. So the form should be something like that we discussed. X minus vt, t minus x by v, x plus vt, something like that. Omega t minus kx, kx minus omega t. Okay. Now
What answer there is?
we will check. According to me, it should be 18th. Yeah. 18th is given A and C. A and C. 18th given A and C. Because that function will be equated with y, na? That's why it will become function. Otherwise, it is just a term. If you are equating with the y, you are not getting anything. Wave is represented like this. You have to exactly find a sine.
kx plus omega t.
This is k.
Omega.
This is omega. Okay. Okay. That is k, that is omega. So in that case, what we have to find, what is given positive, negative, negative, positive. First thing is sure it is going in the negative direction. There is not a single negative sign here, so it is going in the negative direction. There may be two negative, there may be no negative. That means negative is taken out, so it will be all positive. So it is going in the negative direction. How many options are there? Second or third? You can find the velocity omega by k
3 by 2 point
1.5. So it will be second option. Clear?
Wavelength is 2 pi by lambda.
Which one?
2 pi by k.
Huh?
We'll get 0.2 also. Third option also we get. C.
Acha, that is different thing, right? Wavelength 0.2. If I am trying to find wavelength, 2 pi by k. So 2 pi by 10, 2 pi upon 10k, 1 by 5, 0.2. C is also correct. That will be multiple choice. I thought there will be some one answer. That's why I moved ahead. But anyways. Take this one. 22. The transverse harmonic wave on a string is given as this the wave velocity. You can find it out. It's not that easy. Now these questions you can solve, right? Okay, let's move ahead then. I am considering that you can solve this question now. This is given phase omega t case. It is all the same game. Let's check.
The waveform means equation.
Try this
Waveform means equation.
equation. What kind of wave is that? Waveform means I think we have to create the equation here. Nothing, you have to create the equation. A sin omega t plus kx plus phi, something like that. Create it. Create the equation. This is a bit different, maybe a bit lengthy. Solve it. Do it quickly. I have some more questions which I was planning to solve from this part itself. We will solve them. Okay. Let's solve. Maximum particle velocity will be a omega, and a omega is how much? 3, and a omega square is how much? 90. Dividing them, omega will become how much? 30 radian per second. We got omega. V is given. V is given. So V is given 20 meter per second. Okay. So in that case we can find K. K is going to be 30 by 20. That is going to be how much? 1.5. Okay. Now we got K, we got omega, and maximum particle, yeah, A we can also find. Omega is 30, so we can take A into 30 equal to 3, so A will become 0.1. Okay, so we can write the equation y equal to 0.1 sine omega is how much? 30 t minus or whatever is the phase there, whatever is the phase there. Okay, clear? This is subjective question 2005. So in that case they would be checking it, the paper themselves. Even if you are taking plus or minus, that will be considered correct, not an issue. Okay na? Yeah, now there are some good questions. Try these ones. forget this one for now. Very old question, so chances are very less they will be asking again. Start from this one, numerical part. A steel wire is with mass is given, under tension is given, speed of the transverse wave. Simple question. What is answer? Kadir? 100. Okay. Krishna, which formula we will be using here? Yeah, last bench. Which formula? Simple, yeah. T by mu we will be using. We will solve it. Under root T by mu we will solve it. Okay. You can all do it. Okay. So it will be T by mu. Let's start. Go with the third one. A thin rope of length 12 and mass hang vertically from a rigid support and the block is attached to its free end. The transverse wave of wave 6 centimeter of wavelength 6 centimeter is produced at the lower end of the rope. What is the wavelength of the wave train when it reaches the top of the rope? Velocity is equal to what? Wavelength into frequency. Wavelength into frequency, right? Okay. So if you are keeping the frequency same, velocity will become proportional to lambda. That kind of concept will be applied here. Try now.
I thought it's like V equals to root T by mu here tension.
Tension is same. Tension is not an issue. Okay. Tension we will get. They are saying wavelength when it reaches the top of the rope.
No, rope has mass.
Eh?
Rope also has mass. Then tension we have to integrate.
Acha, tension will change at each and every point, na? Not an issue. That is not the problem. But he will find what he will find it. That is the question. Thin rope of length 12 and the mass 6 kg.
By integrating, we get a constant acceleration and we use Newton's formula. Motion.
No, that is not the problem. I am saying if we are trying to transfer wavelength of wave, acha, at the bottom wavelength is 6 centimeter. Okay. And on the top you have to find the wavelength. That is the question. No?
Then finding velocity, we can find Newton.
So how much initial velocity you are giving? That is also the question. No? How you will be equating v1 by v2 equal to lambda 1 by lambda 2. No? So lambda 1 and lambda 2 are fine. You have to find one lambda, other lambda is given. What is the initial velocity you are giving here? Okay, take 0, then solve. Solve it, try it. Transfer short wave train of wavelength 6 centimeter produced at the lower end of the rope. What is the wavelength of the wave train when it reaches the top of the rope? So if you are having a rope horizontally, okay, then the tension, it doesn't matter. Then it will be having some mass per unit length and you will be applying the velocity constant under root T by mu. When it is vertical, tension is changing. So as tension is increasing, velocity will be increasing as well. Okay. So you will have to do differentiation and you will find the final velocity. That is not a problem. I am saying how you will be finding the lambda over there. How do you know the frequency? Okay, let's first find the velocity at the top. Then we will think about it. First find the velocity at the top. Then we can think about it. Why do you need to integrate? That is what I was thinking. First of all, my one confusion is clear. I was thinking at the bottom there will be no tension, so velocity will not be. No, bottom and there will be tension because it is hanging. That was my confusion. If you put that value 0, everything will get nullified. Okay. So the thing is, see, no, it is not that difficult. If you are trying to find, see, in this question what is difficult, if you are trying to find the time, because velocity is not constant, velocity is increasing, because velocity is proportional to root t by mu. Got it? So if somebody asks how much, I think there is a question here, we will check. From this point to this point, if this is the length of the rope, how much time is taken by the wave to reach upward? In that case, you will be requiring integration, because you will be doing a summation. How much traveled here. Velocity is not an issue. I will tell you how. How much is the tension here? I will take the tension T1 here. It is given how much? 2 kg. So this will be 20. Okay. And the rope is having how much mass? 6 kg. And length is how much? 12 meter. So tension here at the top will be how much? 80 Newton. Understood? So velocity here, it will be, if I take the proportion, if I take V1 by V2, okay, it will become how much? No, V is proportional to T, no? So 20 by 80. Got it? And this should be equal to how much? That is what I am trying to say. You don't need to find, first of all, why you are adding the velocity, why you are integrating it. When you know the tension at a particular point, the velocity will be directly under root T by mu. What is going to be the issue? Yeah, if you have to find the time in this case, velocity is changing. That will be a different task. We can try that. How much time is taken by this wave to reach from this point to this point? We can try that. Okay. We will try that in this question itself. First of all, let me cross check it. How much lambda initially is given here? 6. So 1, it will become what? 1 by 2 equal to 6 by lambda 2. Lambda 2 is coming out 12 centimeter. Clear? That is clear. Now my question is, I am changing the question. How much time will be taken by this wave to reach from this point to this point? That is the question. So what I will take? I can take x from bottom or top. Wherever I can take, the answer will be same, not an issue. I am taking a small element here. How much length? Dx at the separation x. Got it? How much will be the tension here? If I take the tension there at T, how much will be the tension? 20 plus mass per unit length. Okay. mg of this, right? So it will be 6 by 12 into g. Got it? So it will become 2 5x. If I can write it like this, right? I am taking the value of g as 10. Okay. So it will become 6 to 12 to 5x. Okay, that is a tension. So how much time is, yeah?
For mu, like that mass is attached, so how will mu change?
Mu? No, it will not change.
It won't change.
Inextensible. We take the string inextensible. Okay. Due to its own weight, tension will be different. If you are hanging something 230 kg, tension will change. Mass per unit length will not change. Okay. So this is the tension I am getting there. Okay. Now in that case, how much is the mu here?
6 by 12.
0.5. We can use it anywhere.
6g. Mass per unit.
Mass per unit length.
Ma-
6 kg divided by 12 meter. Clear? So this will be this divided by this. That's what I have written here. Now my question is, how much velocity will be here?
20 plus 5x by into
Like this. And how much time it will take? Velocity equal to distance upon time is distance upon velocity.
dx by
So
dt.
yeah, so small time dt will be dx divided by v. Got it? Distance by velocity, right? Time equal to distance by velocity. So velocity will be how much? As you were saying, 0.5, I can write 2, 20 plus 5x. Now I can take time 0 to t and I can do the integration from 0 to 6. Here we need the time.
12.
Acha, 12. Length is given 12. Got it? Here we need the integration. So you can note it down if you want, because a question has been asked. I think it is there, maybe the next page. So this is how you find it. For the small part, you are going to do the addition of time. You don't need the addition for velocity, obviously. If you are trying to find some average velocity, something like that, then you will be doing the integration somewhere, maybe. So this is time taken to reach top. This is what this is. Time taken to reach top. Meka, you didn't click my picture, no? You have clicked time. Why? Click proper picture, not an issue.
Group icon.
Huh?
Group icon.
Vishal has taken that kind of picture which I am looking more sad, like this. I was tired maybe. Now you can click this picture. Now you can click.
So this is clear.
Huh?
It is clear.
Anyways, no, I was covering that part. No, that's why I was saying you can click it now. No, you can try clicking it now. Do it. I will photo bomb like this. I will photo bomb like this. All of a sudden. Done. Next question. Question number 4. Three waves having equal frequency and the same intensity I naught, they have the phase angle 0, pi by 4 and minus pi by 4. When they are superimposed, the intensity of the resultant wave is close to 3 I naught. Sure? Think about it.
We take phasor diagram.
Take it. Take them as vectors, not an issue. You will not be getting 3. You will take the components, you will be finding the resultant. One you can take, one will be pi by 4 here, one will be pi by 4 here. So that is pi by 4.
Okay, so you take pi by 4 here, pi by 4, that component will be cancelled.
Their vertical component will get cancelled and here it will be added.
And
Yeah.
it's coming like root 2 plus
How?
1.
Eh?
Coming root 2 plus 1 I.
So that will be, I think, root 2.
1.4.
How much it is coming? Root 2?
Root 2 is 1.4.
Root 2 plus 1. Okay. Not an issue. We will check. We will check it. I naught frequency, same intensity. When they are superimposed, the intensity or resultant. So you can take one I naught like this, one you can take like this, and one you can take like this. So this is how much angle? 45. So they will get added here, their component will get added here. Okay, I naught by root 2, I naught by root 2, and there this component will get cancelled. Okay, so it will be plus I naught, it will be this one I naught I have taken, right? Okay, now this will become root 2 I naught plus I naught. Okay, close. Acha, 1.4 plus 1, 2.4. Then answer should be this one, na? Okay, clear. This has to be the answer. We will check it. They have given A 5.8. Are we doing any mistake here? It will become square of that. We will be taking amplitude here. Yep. We will not be taking this intensity, right? We will be taking this as amplitudes.
For phasor diagram, we won't take intensity.
Why? We'll be talking about amplitude now. How much you are getting this?
Root 2 plus 1 into 2 right?
Square, this we are getting. This is resultant amplitude we are getting.
So
So square of this, how much it will be?
0.76.
That is how this is answer. This is not.
So whenever we take phasor, we take
Amplitude. Amplitude will be the magnitude. That's what I was thinking, that you cannot take I naught. Intensity will be proportional to amplitude square. So phasor diagram you will be taking the amplitudes. Try this. Pressure wave is given, that is change in pressure is equal to maximum change in pressure. Okay, that kind of equation is given. Correspond to the sound produced by the vibrating blade when the atmospheric pressure is 0 degree. Some other day when the temperature is T. The speed of the sound produced by the, okay, when you are increasing the temperature, the speed of the sound produced by at the same frequency is found to be 336. How you, there has to be relation speed of the sound between and temperature, which I don't eh? No, temperature at a higher temperature, velocity at higher temperature is equal to V naught minus or plus 1.6 something like. There is a relation to that. On the basis of that you can solve it. Leave question number 5 for right now. Okay, there is some relation with the temperature.
no, like pressure wave means pressure amplitude is BA km dkV.
Pressure amplitude is given 0.01.
BKA. B will be bulk modulus. Then the bulk modulus may be.
We will check this question. First we will discuss the pressure wave then. Okay, clear? Try sixth one and give me pen. Let me mark these questions because the theory we have to discuss first. Fifth one, there was another question.
True or false statement?
This one, we will discuss that. Not an issue. Check sixth one. This one. Fifth, leave it for now. We will discuss it in detail when we will be discussing pressure wave, because question are not asked. They have asked 2019. Otherwise, you will not see the pressure wave question anywhere. This is the only question they asked. So we will check the theory first. Then on the basis of that, we will discuss it. Again, beat frequency. P upon rho will be T, T1 by T2. It's not that tough, it has nothing to do with that. Yeah, we will check that question as well. We don't need a relation, there is a derivation based on that. Speed at a particular temperature T is equal to speed at 0 degree plus 1.6 or minus. We don't need that actually, that relation. Solve sixth one.
B.
Hmm?
6B.
Sixth A. A we are getting.
Not coming exactly.
Hmm?
Not coming exactly.
Not coming exactly, absolutely. How much it is coming? Under root 1 upon 2 pi?
It's,
Something like that they've given. First of all, we will do what?
10 log 10.
We will, when it is clearly visible, they have given something like this. We can write 120 equal to 12 ln I upon 10 raised to power minus 12. So this will become 12.
Not ln, let's say log
Log.
base 10.
Okay.
10 power 12 into 10 power minus 1.
So what is the value of I?
I is 1.
I is going, achha, this will become 12, that will go 12, okay. So from, even if I am not thinking about antilog, the value of I will become 1.
Sir, sorry to disturb.
Yeah.
Sir, for tomorrow's question paper, is it ready?
Huh?
Tomorrow's question paper test.
नहीं है, didn't get time.
नहीं हो रहा।
टाइम ही मिला है।
कल सुबह मैं इसलिए पूछा।
कल सुबह ही भेज पाऊंगा मैं, वही होगा। कितने बजे?
9 बजे सर।
कोई नहीं, फिर आज शाम को भेज दूंगा, ये होगा। टाइम ही नहीं मिला यार, क्लास लगा था बढ़िया,
ठीक
है ना? तो मैं कुछ बना के भेजता हूँ फिर। Okay, so now in this case,
Power by
है?
power by equals to
ठीक है, so intensity is what? 1, that is equal to 2 upon 4 pi
r
r square, okay, clear? And r square will become
1 by 2 by
2 pi
r equals
1 by 2 into 3.14 meter, okay. So if given centimeter, then 1 meter equal to 100 centimeter, so 100 divided by 6.28 meter, how much it will be?
40.
Approximately 40, approximately 40, okay na?
6.28 we take as 6.25 means it becomes 2.5.
2.5 and 100 divided by 2.5, 40, है ना?
2 by 5
Done, not an issue. And this question also they given, there is nothing here, okay. Pressure is going to be proportional to root t, velocity of sound is going to be proportional to root t, okay. So when it is given at 0 degree, can we first find the velocity in this from this data? How much is going to the velocity? Omega by k. 1000 by 3. So that is going to the velocity at 0 degree. So 0 degree velocity is going to be how much? 1000 by 3. Okay. And at temperature T, this is the velocity 0 degree. At temperature T, the velocity is given how much? 336. So here we can find velocity is proportional to root T. And then you can solve it. Is lengthy. Okay. But this is, there is nothing more here. That's why they have added in this part. So you will be writing what? 1000 divided by 3 divided by 336, okay, that is going to be what? It is going to be root of 273 plus 0, 273 plus t, and then calculating it and getting your answer. If you can do the calculation of this, then you can try to find the answer. You have to use the calci. Can you find, let me know that this ratio, how much will be this ratio? 1000 divided by 3 into 336, 18, 1, 10, 1, 1000 upon 1008, okay. How much it will be? 0.99, okay. So it is going to be, and square of this 0.99 into 0.99, I think it will become smaller, 0.98 or something. 0.98. So it will be 0.98 equal to 273 upon 273 plus t. So it will be how much? 0.98 into 273 plus 0.98 into t equal to 273. Okay, so this is you have to solve and you can get your answer. Approximately if you see, it will be
267.
2, and then it will be 273 minus 269, 6, 0.98. So t, answer of t will be 6 divided by 0.98. 6 divided by 6.1 Kelvin, right? 6.1 Kelvin. So it will be how much in degree?
4
No, wait. 6 divided by 0.98 will be. So what we are getting here, we may have done some mistake.
4.3 and 4 degrees.
Approximately if you see from here, 273 plus 0, not much change is there. This will be how much? 333, right? 1000 by 3 will be 333. 333.
We'll reciprocate it. That will become like 1.008 whole square. 1 plus nx is 1 plus x power n when x is very small.
Acha, binomial.
Binomial.
We can apply that. But anyways, how much is the answer coming?
4 degrees.
Okay. This question is this
P proportional to root t from where it will be.
V equal to P by rho,
P by
NRT concept, KTG concept. Okay, now from there. There is one more derivation. Why I left the question? Because I thought that will be applicable. Velocity at a particular temperature T is equal to velocity at 0 degree minus 1.6, there is a derivation, small derivation, there is a relation which I forgot to write here. Write in the, okay, you can check it in the numericals or any formula book, but that is not applicable. Here you can take the ratio and get the answer. This is related to beat. Okay, so leave it for now. Try these ones. A uniform string of length 20 meters is suspended from a rigid support. A short wave pulse is introduced at the lower end. It starts moving up the string. The time taken to reach the support. It is very easy, I think. Solve it. Time taken will be distance upon speed. Distance is given how much? 20 meter. Speed you can find. Now try to find the relation. I think mass will get cancelled, something like that. Okay. Uniform string of length 20 meter starts moving. The time taken to reach the support. How much will be the time taken? Distance, that is 20 meter, divided by speed. Speed will be how much? Oh, that is a point. Now now that is a point. You can take a particular mass m and then you have to find t will get somewhere cancelled. It will be something like that. Now this is a good question. That's why it is asked in 2016. Okay, not take. We will take 20 meter rope having how much mass? M. Okay. Now in this case, the same way we have taken the time in that case, na? We will be doing it the same way, right? So dx I will take here at x. How much will be the tension here? M by 20 into dx. Sorry, into x, because this mass we will be taking, na? Yeah. So it will be
mg, no?
x into g. Clear? So this is the tension. So how much will be the velocity here? If I'm
dx by dt will
ठीक है. So no, what you are trying to say? I am saying if I can find that this time and I can add it, we can take
b equals root t by mu, where the v will write dx by dt and this will get as a function of this
dx by dt equal to root t
by mu.
by mu.
Mu
Okay.
is 20 by mu.
So dt is going to be mu by t dx. Okay. And the tension is how much over there? At this portion, mu is given m by 20, and tension is given how much?
1 by 20 xg.
mxg by 20. So this is getting cancelled like this. So you are getting 1 upon root g dx upon root x dt. You have to find total time, and x you can take how much? 0 to 20. 0 to 20. So this will be t equal to 1 by root g. So this will become 2 root x. 2 will be here. Root x. So root 20 minus 0. Root 10 here, root 20 here. That will get cancelled. So you will get 2 root 2 second. Okay. Good question. Next one.
That's Doppler. That is Doppler.
No, it is not Doppler for sure. Try it without Doppler. Maybe it is not Doppler. It is normal. It is reflecting. You have moved ahead. How much time? Something like that. They are saying the engine approaches a hill with a constant speed. When it is at a distance of 0.9, it blows a whistle whose echo is heard by the driver. So when you are blowing a whistle, so it will be coming back to you in 5 seconds, right? So you are whistling it at 0.9 kilometer separation, right? Okay, kind of relative concept. And if the speed of the sound in the air is 330, then the speed of the engine. Kind of motion in 1D question. They are not asking about frequency or wavelength here. If they ask it, then it will be Doppler. They are not asking about that. It is simply motion in 1D question. Try it quickly. We will solve till 11th. Anyhow, we have to solve in this class up to 11th. Okay. Try to draw the diagram. You will try. You will try. You have to find the speed of the engine. So this is engine. It is moving with some velocity v. It is at how much separation? Okay, meter per second. So 900 meter. It is at the separation of 900 meter. Okay. Now in this case, it is at 900 meter. Then it blows a whistle. It blows a whistle whose echo is heard by the driver after 5 seconds. So it means it is whistle. I can take this whistle, for example, like a bullet. It is moving with how much speed? 330. It will collide here and it will come back. Okay. It will be like this. Okay. So in that case, you have to find the speed of the engine. 30 meter per second. Okay.
Approaches a hill means will the velocity of wind be like this or this?
It blows a whistle. That is not given, na. You are taking it as a vacuum. Wind is not disturbing it. The speed, this whistle, it is going with how much speed? 330. Engine is also going. It will collide here and it will come back by how much? 330. That's it. And it will meet the engine somewhere here. Got it? What is the issue? Where you are getting confused? The question is very simple. What you are thinking? Sound is moving with 330, colliding, coming back with 330. It is meeting engine. How much is the velocity on the engine? It is meeting how much time? 5 seconds. It is meeting in 5 seconds. Okay. So it's clear now. How much this traveled in 5 seconds? Sound traveled 330 into 5. How much it will be? 0.1650. Clear? So sound already traveled 900 and coming by how much? 750. Got it? That much engine traveled. You all can see sound traveled 1650. So this is 900 and then 750. So that means engine traveled how much? 150. If the engine traveled 150 in 5 seconds, okay, speed will be how much? 30. That is the question. Getting it now? Yeah, no confusion. I hope. It has nothing to do with the wind or all that concept. This one? Question number 10. You have any other class after this? You will be leaving at 5 exactly. Parents are coming. Okay, we will solve in the next class then. Okay. Huh? Try then 10th question, last question. 10th and 11th. Finish it off quickly. 3-4 minutes. They are saying wave along a string, the wave moves along a string in the positive direction at the speed of 10. Wavelength is given, amplitude is given, particular time t, the snapshot of the wave is given, the velocity of the point p when its displacement is 5 centimeter. Okay. Now again the same concept, velocity of the particle is minus v of the slope. Slope is what in this case? Negative. So velocity will be positive. So it will be moving in the upward direction. If it is moving in the upward direction, A is going to be the answer. Simple logic. Done. That is the logic. Got it? Instead of solving and doing everything, in case if they are given j cap gave up, then you have to solve it. Got it? 11th. Okay, if the string is C, if the particles on the string is doing SHM, that is clear. When it will be having proper potential energy, all the energy, mechanical energy is potential. Peak. That is where they have maximum potential energy. Got it? When they are having maximum kinetic energy? At the mean position. Now that is the concept. If they will meet, they are saying the speed is 2 centimeter, 2 centimeter. After 2 seconds, if they meet these two, they will nullify. Okay. They will nullify. It will look like this. But actually, it will look like this, but they will be having kinetic energy. Getting it? So it is not kind of nullified. They will be having some only pure kinetic energy. They were having, in this case, they were having what? In this case, we were talk about the top. Converted into kinetic. Converted into, nothing is lost here. After that, they will again move like that. They will be having same shape. It is not like that they get nullified. There are two waves. Okay. It will look like this at this situation. After that, the same diagram, it will look like this. Just after 1 second. So at that instant, they are like this. So it is entirely kinetic. Got it? Okay. Next class we will see the rest of the thing.